Hello everyone, welcome to my math tutorial number 49, dated 9th July 2025. My name is Mr. Lovex Israel Orengo. The topic of today is Logarithms Part I. The subheadings under this lesson will be logarithmic notation, logarithms of numbers from tables, that will also involve anti-logarithms of numbers from tables, and finally operation on logarithms. Operation logarithms, I mean or I refer to adding logarithms, subtracting logarithms, dividing logarithms, multiplying logarithms by numbers. Welcome. Logarithmic notation. Logarithm is the power to which a base must be raised to yield a given number. If x is the logarithm of a to base b, then b raised to x equals to a. That's in index form. For example, 2 cubed equals to 8. 2 raised to 3 equals to 8. That is in index form. Now, in a logarithm, 2 cubed equals to 8. 3 is the logarithm of 8 to base 2. That power, that index, is known as the logarithm of 8 to base 2. Mathematically, in logarithmic notation, you write logarithm. In simple terms, in abbreviation, you write it in, or in short form, you write it log. Logarithm of 8 to base 2 equals to 3. I repeat, it is read as logarithm of 8 to base 2 equals to 3. When we write this logarithm notation, 8 is written as in a larger, maybe the size of 8 is larger. 2 is written as a subscript at the lower level of the logarithm or of the linear equation, and it's written in a smaller size. Note that if a equals to b raised to n, then logarithm of a to base b equals to n. For example, 5 raised to 1 equals to 5. That means log 5 base 5 equals to 1. 3 squared equals to 9. That's index form. In logarithm form, logarithm of 9 to base 3 equals to 2. 10 cubed equals to 1000. In logarithm form, logarithm of 1000 to base 10 equals to 3. 9 raised to power a half equals to 3. That means logarithm of 3 to base 9 equals to a half. In some cases, the bases are not indicated. If the base is not indicated, automatically the base is 10. Logarithm of a base b equals to n is read as logarithm of a to base b is equals to n. Logarithm of numbers from tables. Logarithms are read from mathematical tables to the base of 10. For a number a, logarithm of a to base 10 equals to n. That means 10 raised to n equals to a. Logarithm of a from a table is the power to which 10 can be raised to give a. I like to repeat that one again. Logarithm of a number a from the table is the power to which 10 can be raised to give that a. Steps to read the logarithm from tables. Express the number in standard form. That's a times 10 power n. Step 2. Read the logarithm of a from the table of logarithms. We read the logarithm of a. Note that n is the whole number part of the logarithm or of the answer in step 2. Then the decimal part of the logarithm of a. Therefore, the value of n under the expression in power in standard form, n is the whole number part of the logarithm, and the value we read from the logarithm table is the decimal part of the logarithm of the number that you are given. Therefore, if n is negative, it is written as that negative sign is put on top of n and read as bar n. For example, if n equals to negative 3, then we have bar 3 and read as bar 3. Point. Like that. Example 1. Use logarithm tables to find the logarithm of 7.573, B 89.395, C 4789, and D 0.00389. Solution. 7.573 equals to 7.573 times 10 power 0. Logarithm of this number from the table gives us 0.8793, and this power of 10 is 0. Therefore, we say 0.8793. Logarithm of 89.395 in standard form, that's 8.940 times 10 power 1. We have written the number in first kind of figures because we are going to read for the number from a 4 figure. If the number has more than 4 digits, you have round down to 4 digits. Now from the table, logarithm of 8.940 is 0.913. But here the power of 10, that's n, is 1. Therefore, the answer for the logarithm becomes 1.9513. Part C, 4,789. For that case, in standard form it is 4.789 times 10 power 3. Now the answer is 3.6802. For 0.00389, standard form is 3.89 times 10 power negative 3. Therefore, the answer will be bar 3.5899. Let's move to nth logarithm. This is the reverse of logarithm. An nth logarithm is the number obtained when a given base is raised to the given power, or logarithm. From tables, an nth logarithm is the number obtained when 10 is raised to the given logarithm. We have tables of logarithm and tables of anti-logarithm just after the tables of logarithm. Therefore, we will use the tables of anti-logarithms to read the anti-logarithms of various logarithms. Example 2. Use anti-logarithm tables to find the number whose logarithm is, these are logarithms given. I've started with the example that were in example 1. Hint, read the anti-logarithm of the decimal part of the logarithm. Then multiply the answer by 10 raised to the whole number part. As we had said, we are doing the reverse. In the logarithms, we read the logarithm of A, then we took the power of 10 as the whole number. Here now, the reverse, we read the anti-logarithm of the decimal part, then we multiply by the 10 raised to the whole number part of the logarithm. The antilog of 0.8793 equals to 7.573, which is the antilog of 0.8793 times 10 power 0 gives us 7.573. That's example 1 in the previous section. Antilog of 1.8328, we take the antilog of 0.8328, which is 6.805, 10 times 10 power 1, where 1 is the whole number out of this logarithm, we get 68.05. The antilog of bar 2.3825, we take the antilog of 3.3825, which is 2.415 times 10 power negative 2, which is from bar 2. We get 0.02415. Antilog of 3.1287, that is the antilog of 0.1287 is 1.345 times 10 power 3, which is from this part. Finally, we have 1,345. The antilog of bar 1.587, that is the antilog of 0.587 is 3.864 times 10 power negative 1. Because of this bar 1, we have 0.3864. The anthrop of bar 3.0357, that is the anthrop of 0.0357 is 1.085 times 10 power negative 3, giving us 0.001085. Let's move to the last part of this lesson, that is operation on logarithms. The operation include addition, subtraction, division, and multiplication. Example 3. Evaluate each of the following logarithms without using a calculator. Part A, we have 0.3873 times 3. Now I'd like to continue directly from the solution because the question I repeated there. 0.3873 times 3. We multiply that number manually. We get that is 9. 21 carry 2. That is 24 plus 2. 26 carry 2. 9 plus 2, 11. 1.161. For part B, 1.8728 times 2. We multiply it. We get 3.7456. For part C, I want us to put focus here. Let us focus here. Let us be very much attentive here. When it has a bar, for the first cases A and B, where the logarithms are not having bars, they are all positive, we can even use a calculator to verify our answers. But for the case where we are having bars, we should not use a calculator at all. Now, in this case, we multiply as follows. 2 times 2 get 4. 2 times 7 we get 14 carry 1. 2 times 8 we get 16 plus 1 17 carry 1. 2 times 9 18 plus 1 19 carry 1. Now we have carried 1 here, but we have 2 times negative 4 negative 2. Now we get negative 4. Now that negative 4 plus the 1 we carried, we get to negative 3. Then we write bar 3.9744. For part D, we're asked to add bar 3.8728 plus 1.7825. When we are adding, we add manually. That's 8 plus this is 13 carry 1. This is 4, 5. This is 15, 5 carry 1. This is 15 plus 1, 16 carry 1, 6 carry 1. Now here we have carried 1, and here we are having negative 3 plus 1. Therefore we are having 1 plus negative 3 plus 1. That gives us negative 1. But we now read it as bar 1.6553. Part E, we are given 0.5721 minus 3.7208. We subtract, this gives us 11, that is 3. That gives us 1. This gives us 7 minus 2, we get 5. Now here we have a 0 and we are carrying. We still carry to this point to get it 15. 15 minus 7, we get 8. But here we had nothing, 0, and we borrowed. If we borrowed, it means we remained with negative 1. That's bar 1. Now we take it as negative 1 minus negative 3 will give us negative 4. We write it as bar 4.8531. Therefore, we can borrow from where we don't have anything. Let's proceed. 1.9820 minus 2.9038. This gives us 2. This gives us 8. This gives us 7. This gives us 0. 1 minus 2 gives us bar 1.0782. G, 0.8724 divided by 3. This one is easier. We just do it directly. We get 0.2908. For H, bar 2.1827 divided by 2. For this case, we have to be very, very, very critical. But for this case, we observe this number under bar. Is it divisible by 2? Yes. If it is divisible by 2, we just say bar 2 or over 2, we get bar 1. Then we divide this one by 2 as well, we get 0.9, that is 0.915. For this case, the bar side is not, the value under bar is not divisible by 3. We must make this number divisible by the divisor. I'm repeating. If you are dividing a number a logarithm by a number and find that the whole number part is a bar and it's not divisible by the whole number part, we make it divisible by that number. This is how we proceed. This concept will help us in the next lesson where we talk about roots. Now, we look for a number more than 2, which is divisible by 3. Then we could look for multiples of 3. That those are 3, 6, 9, in that order. We look for a number which comes after 2. That's 3. That we now make this number bar 3 or over 3. But we ask ourselves, which number can we add to bar 3 to get to bar 1? This is, which number can we add to negative 3 to give us negative 2? It's plus 1. Therefore, we take bar 3 or over 3 plus the one that we have taken, 1.8105. Therefore, that one we have gotten, we attach it direct to the decimal part. We also divide it by 3. We get bar 1. The answer we get from here is our number. The answer we get here is a decimal part. Therefore, we join them directly without adding. We say bar 1.6036. Bar 1.8326 divided by 4. We make this number divisible by 4. We move to 4 so that it is bar 4 or over 4 plus 3, because we have moved for 3 steps from 1 to 4. When you add negative 4 plus 3, we get back to negative 1. Now 3.8326 divided by 4. When we divide, we get this part bar 1. For this case, we get 0.9582. Therefore, the answer is bar 1.9582 to 4 significant figures. Thank you for watching. We are going to apply the concept that you have learned here in the subsequent lessons.